All right, welcome back to class. We're going to start on Chapter 5, Conditionals and Loops today, and hopefully you're getting much more comfortable with using Python at this point. So you should open your terminal. Here is the prompt for the terminal, and as always, enter the interpreter by simply typing Python 3. So conditionals and loops, these are some of the most useful statements that you can use in Python. You'll find yourself using these all the time once you get more comfortable programming. And there's a couple reasons to use these. One is that you often ahead of time don't know what sort of data that might be entered in a program. So, many scripts and many commands, for example, take in some sort of data or some sort of argument from the user. At the command line we saw this, and if you wanted to change directory into a directory within that directory, you use the cd command. And there are a number of different directories that you could change into. So desktop is an example, documents is an example. You can also give it incorrect information, for example. So instead of writing documents, maybe I misspell it and I call it documents. And so that is not going to work. So when you're creating a script or you're creating a program, very often you want to do some sort of error checking, for example, to determine if the argument or the data that the user entered is valid. Or maybe you want to do something completely different. So we also have flags within these arguments, and so you want to change the behavior of the program based upon whether or not the user has given you flags. And so how do you determine whether or not that has happened? And so this is an example of where if statements can be very useful. So the basic structure of an if statement is this. So you have to start with the keyword if, and then you have some sort of conditional, and this is not in parentheses, and then after the conditional you have a colon. So let's try this out. So we're going to create a variable called x and set it equal to 0. And we are going to test whether or not x equals 0. And if it is, then we're going to do something. And we are going to set y equal to 1. We are going to print out the version of y, and then we are going to quit. All right, so x is equal to 0, y is equal to 1, so we've managed to go into this loop and run it. So why do we do this? So first, this is the conditional, so the conditional is x equals 0, and one of the things you might notice is that there's two equal signs next to each other. So why are there two equal signs next to each other? So this is because we often use equal sign for two completely different things. One is the assignment. So if we want to assign a variable as a certain number, or if we want to assign it as a list, for example, we can do that. And we use the equal sign in order to do that. But really what we're saying with this equal sign is x equal to this. What we're saying is set x equal to this. So this is called the assignment operator, and we use a single equals for that. So in Python, the other way you might want to use the equal is the conditional. So we are not setting x equal to 0 by doing this. We are asking the question, is x equal to 0? So we have to use two equal signs if we want to ask the question, is x equal to 0, versus telling it set x equal to 0, which is the single equal sign. So we have our if statement, and then the conditional is here, and then if this conditional is true, it goes into the block of code that we write. And whatever we want, we can write. Sorry. Let me try that again with the correct syntax. So we can put as many lines as we want within this code. We can do as many different things as we want. And the way Python knows how many things we want to do is that each one of these lines must be tab indented. So just simply tab indent everything that you want to go within this code block right here. If the conditional is false, if x equals to 1, and so we ask the question, is x equal to 1? It's not equal to 1. And lo and behold, nothing prints, and that's because the conditional was false and we never entered the loop. You can see what is returned by, so this is just like a normal operator, so you can see, for example, what is returned by this if you want and just type it out. So this is just a way to verify what you think is going on. So what sort of variable is being returned by this statement right here? X equals 1. So you can use the type, for example, and you can see what is returned is a Boolean type object. So these conditional statements return Booleans that are either equal to true or false. You can also, and this is really all the if statement cares about. If true, so you can see this works because all the if statement cares about is if the conditional that you return is equal to true. And if it's not, if it's equal to false, you can see you never actually enter that code. So the indented code only runs when the conditional is true and not when the conditional is false. So there are a number of different comparison operators that you can use. So x equal to 1, so that is false. X equal to 0 is true. So this is the conditional equals. You can also do not equals. So is x not equal to 0? That's false. But is x not equal to 1? Yes. It's not equal to a lot of different numbers. So if you want to say not equal, you use the exclamation point followed by the equal sign. You can also do less than or greater than. So x is less than 0, false. X is less than 1, true. X is greater than 0, false. X is greater than -1, true, for example. Less than or equal to, kind of the same, just a little bit different. True, true, false, and then so on. True, true, false. So you can kind of play around with this to see how it all works. So you can also test multiple different things. So let's say you have a program where you want to do something if x is equal to 1, do something else if it's equal to something else, and do something else if that third conditional is true. So you can actually run a bunch of different conditionals. So let me think, like a good example of that is, so let's say you have some a nucleotide. Okay. And so I'm going to create some code that just prints out the name of the and let's just do this in a script, just it might be easier. Okay, so this script will print out the name of a nucleotide given the 1 base abbreviation. So as an example of how you can use multiple if statements to do this, then an example of this is DNA. So so if nucleotide equals A, print, and I'm going to save this as a Python script. If nucleotide equals A, print adenosine. actually, what are the... I actually kind of forget the names, so we are going to look them up really quick. Adenine. Adenine. If nucleotide equals print cytosine, if nucleotide equals print guanine, if nucleotide equals then print thymine, if nucleotide equals U, print uracil. So one of the things we could do is create something like this, and actually we'll just take input, so nucleotide equals input. What nucleotide would you like to know the name of? Okay, so what have we done? We've created a line that will take input from the user, and then if based upon this information, it either prints adenine, cytosine, guanine, thymine, or uracil. And so this is one way we can write the script. This is not the correct way. This is not the best way to write the script, but we'll see in general it does what we want. So we are going to quit, and then we are going to run the script. What nucleotide would you like to know the name of? So C, and that's equal to cytosine. A, adenine, etc. But what if we accidentally mistype and we give it, something that doesn't exist? So basically it doesn't run. So what we really want to do is also have a condition where none of these letters were used, and then we print some information about that. So how do we do that? So what we want to do is first we want to change these if statements to what are called else if statements. And then we also want to add a else statement like this. All right, so now let's rerun it. A, all right, adenine, C, cytosine, G, guanine, T, thymine, U, uracil. And now what happens if we do the wrong one? X, not a valid nucleotide. All right, so this script is a lot more useful because it also gives some information if there was a mistake that was made. So if the nucleotide equals adenine, what we see, it prints it. And then this next says, okay, only enter here if this nucleotide, if the nucleotide is an A. So what this elif statement is, it's shorthand for else if. What this means is that only look in this conditional if this was already false. So if this is true, it's going to skip to the end. But if it's not, so if the nucleotide doesn't equal A, then check this. If the nucleotide equals C, print this and quit. Otherwise, continue on to the next else if statement, and then so on and so forth. If none of these conditions are true, then what else does is it says, do this no matter what. So if none of these conditionals were true and we didn't enter any of these loops, these if, the codes for the if, then we end up going to here and printing out a nucleotide. So something like this. let's kind of just test some stuff out and see how well we understand this. So if x equals 1, print x equals 1. If y equals 1, print y equals 1. All right, and we'll remove this. All right, so let's predict what's going to happen in this case. X is equal to 1, y is equal to 1. If x is equal to 1, then print this. If y is equal to 1, then print this. So this should print out both of these statements. And let's test this and see if that works. Yep, that works. And I have an extra equal sign, just like we thought. But if we change it to elif, let's see what happens when we run this code. So now only the first statement runs, and that's simply because once you enter one of these, then you stop running, and it doesn't matter if this conditional is also true. You never try to enter this conditional. So that's the difference between if and else if, in case you're confused. Hopefully that clears it up a little bit. All right, so if statements, very useful so far. And now let's make them a little more useful. So maybe we want to have a condition where we want to do something if x is equal to 1 and y is equal to 1. So how can we do that? So we only want to do that if both x and y is equal to 1. So one way we can do that is we can do this. If x is equal to 1, if y is equal to 1, and we can get this statement to work. So this is one way we can do something called AND logic. So AND logic means we need two different conditionals to be true. But this is kind of ugly code. It becomes hard to try to figure out what exactly someone is trying to do. So it's actually much better to use what's called an AND keyword. And so we can also write it instead like this. And so now we enter that loop in both different situations. So what this is, and we can actually type this out, so x equals 1. Gotta get back into the interpreter. So x equals 1, y equals 1, and now if x equals, sorry, let's see. So x equals 1 and y equals 1. So So really what you're doing, it might be clear if you kind of like use parentheses to make it clear how exactly this works, is that this if statement still only works if the true statement, if it's true. So if it sees like a true right here, that's the only way the if statement activates and you go into this code. But the way this AND keyword works is that it takes two different conditionals, and if both of them are equal to true, then it returns true, like in this case right here. But if either one of these is false, then it returns false. And we can actually even see this by kind of explicitly doing this. You know, true and false, false and true, false and false. And so that's kind of how the AND keyword works. So this table just summarizes what I showed here. So if the left-hand side is true, the right-hand side is true, and you have an AND statement, then this is true. Otherwise, you return a false in all different cases. There's also an OR statement, and you can do it like this. So if either x equals 1 or y equals 1, you want to do something. So one way we can write that is this. Sorry. Actually, this gets a little tricky. You could write it like this. Or we could write it like this. And now we run it, and in both cases, so this runs, let's say if we change it to 0, and so we're able to run this in both cases. So again, the way the OR keyword works is that you can just test it out. True or true, that returns true. True or false, so now that returns true. So if we use the AND, this would return false. But the OR returns true, and the only time it doesn't return true is if both the left side and the right side are false. You can also use in statements. Sometimes in statements are very useful for using as conditionals for an if. So, let's say we want to test whether or not the user gave us a good nucleotide. So we can create a string. So this is a string object, remember, because we have two different single quotes. And when we do the possible nucleotides, we have 8 different elements. So we see if we run this statement, A and possible nucleotides, it returns true. But if we return something that's not within there, then it returns false. So the in is able to search through a sequence and search to see if any of the elements are equal to this. You can also do it as lists. So let's say we had a list. So we could also do something like this, but anything else is not there. So if we wanted to use this in an if statement, we would do if A, and let's say we have A. Let's just do this right here really quick. So input, so nucleotide equals input, give me a nucleotide. If nuke.upper in ACGT, then print good nucleotide. So now we run this script. Give me a nucleotide A, good nucleotide. If we give it a bad one, then it doesn't print. If we only want this to run if a bad nucleotide is given, then we can add the not keyword in front of it. So if not in ACGT, then print bad nucleotide. So nothing prints unless we give it a bad nucleotide, and then it goes. All right, so in statements are also very useful. And one final thing we'll go over is, I said that if you do something like this, if true, then the if statement will run. But let's go over some of the other ways that make the if statement run. So if we want to see that, we'll just try a bunch of things. So basically what we've done is just created a number of different if statements, and we want to see which one of these conditionals, true, false, 1, 0, will actually activate the if loop, and then we report that simply by using this print statement right here. So now we run it, and so we see there's actually 4 different things that we're able to trip the conditional. So if true, so this worked, but we also see if you give it a non-zero number, so if you give it 1, or for example -1, you get the if statement to work. So the false and the 0 did not work. Python worked, so if you gave it a string, it activated, and then if you gave it a empty string or a none value, it did not actually trip the conditional, and you never entered that code. So it could potentially be a little bit confusing about the exact things that trigger the if statement, but like all things, if you want to figure out how to do Python, the best thing is just to try to test stuff out and to be comfortable with doing little things like this, because it'll really improve how well you can code. All right, so that is it for if statements. Next we will go over loops.